We are looking at a AIPMT question, particularly from vectors concept, right? So two-dimensional motion problem, but could we say vectors also? The problem is like this. Three forces are acting on the body as shown in the diagram. You can see the diagram here. To have a resultant force only along y direction, what is the magnitude of minimum additional force required? To solve this, what I need to do is, I shall find out the x and y component of each of the force and add all of them so that it will have only y component. I will start with first. Let me call this as F1, right? So this F1 can be written as, can be first of all resolved as, you can see this is like this. This will become its adjacent component, that is 1 cos 60. This becomes its vertical component, 1 sin 60. One important thing that I want you to notice is, as the vector is outward from the origin, the components are also outward. This is the positive x-axis I cap, this is the positive y-axis j cap. So I can say F1 as 1 cos 60 I cap plus 1 sin 60 j cap. How much is that? 1 cos 60 is sin 30, that is 1 by 2 I cap plus 1 sin 60 is root 3 by 2 j cap, that is F1. Let's have a look at the other force, that is this force, 4 Newton. This is also radially outward, which can be further resolved into components. This is theta, therefore this becomes an adjacent component, that is 4 cos 30. This becomes the other component, 4 sin 30. As the vector is outward, both the components are also outward. This is negative x-axis, therefore this is minus I cap. So I can express F2 as in a vector format. Its x component is 4 cos 30 plus j cap because it's along positive y-axis, and 4 sin 30 minus I cap because it's along the negative x-axis. So how much is that? 4 cos 30 is sin 60, that is root 3 by 2 j cap plus 4 sin 30 is 1 by 2 minus I cap. So how much is this? 2 root 3 j cap minus 2 I cap, that is F2. Now let's talk about the other force, that is F3. This one 2 Newton. F3 I want to write. Look at this F3. This is also radially outward from the origin. This angle is given to you as 30 degrees, so this becomes an adjacent component, 2 cos the given angle 30. This is also outward because this vector is outward. The other component is this way, 2 sin 30 plus j cap, plus I cap, this is along post x-axis. This is minus j cap because upward is plus j cap, downward is minus j cap. So F3 can be written like 2 sin 30 plus I cap plus 2 cos 30 minus j cap. How much is this? Sin 30 is 1 by 2 I cap plus 2 cos 30 is root 3 by 2 minus j cap. So this is I cap plus minus, because there is a minus, root 3 j cap. This is F3. Now he said resultant force is having only along y direction. That means to say F resultant along x-axis has to be 0. Let's first find out what is that Fx is. Fx means add all I components. First I component is 1 by 2 of I. Second I component is minus 2i. Third I component is plus 1i. So if I take I common, 1 by 2 minus 2 plus 1 of I cap. So this will be 1 by 2 minus 1 of I cap. That is I cap minus 1 by 2 I cap minus 0.5 I cap. I need not worry and calculate the y component because he said y component can be there, whatever it may be, that's not a problem. But this resultant is having x component of minus 0.5 Newton. For not having x component, we shall add 0.5 Newton. This is minus, now we have to add like a plus. That means we have to add it along the positive x-axis. Shall be added along positive x-axis. Anyway, he is not asking along which direction you want to add. That I need not, it cannot be identified in the options. The option available is 0.5 Newton. That's the answer for the problem. So to solve this problem, we are using vector resolution. The only single rule of resolving a vector is if there is a vector going away from the origin A, its components also go away from the origin, right? If a vector is approaching the origin A, its components also approach the origin. Once if we have that understanding and also have having an understanding that positive x-axis is represented with I cap, negative x-axis is represented with minus I cap, positive y-axis is with plus j cap, negative y-axis with minus j cap, we can simply solve any of these kind of problems. That's it. Thank you for watching.